Hey Algebra 2 students, today we're going to take a look at the second day of 7.6. We'll be solving equations that have logs in them. Two types of equations we're looking at, an equation with one log. 3 steps to solve that equation. We are going to isolate the log, change to exponential form, and solve the equation. If there are 2 logs in the equation, well, the logs have to have the same base. We're going to set the parentheses equal, and then we're going to solve the equation. So our first step is to decide 1 log or 2 logs, and that will guide our path for how we solve. So we take a look at number 1. We notice that there's 1 log. We need to make sure that log is isolated, which it is. There's nothing being added, subtracted, or multiplied here. So we're going to take this log form and turn it into exponential form. 2 to the 3rd power equals 3x. So 8 equals 3x. Divide both sides by 3. So the answer is 8/3. Easy enough. Let's take a look at the second one. We notice the difference between 1 and 2. In 2 we have a term being added and multiplied. So same rules for solving equations. We add or subtract before we multiply or divide. So I'm going to start by subtracting 1. I have 5 log base 3 of 2x equals 5. Now I'm going to divide by 5, so I isolate that log term. Log base 3 of 2x equals 1. Now I have my log term isolated. I can change to exponential form. So 3 to the 1st equals 2x. So divide both sides by 2. And I get 3 over 2 equals x. So let's try some more. Maybe. Here we go. Okay, so same thing. I've got 1 log. I notice I have this times 4, so I have to start by dividing out that 4, and I get log of 3 x minus 1 equals 5. Now I can change forms. 3 to the 5th equals x minus 1. So 3 to the 5th power is 243 equals x minus 1. Add 1 to both sides, and I get 244 equals x. Alright, so 1, 2, and 3 all involved a log. If you look at number 4, notice that number 4 is natural log. So a little side note over here, that remember that natural log is the same as log base e. So first let's start by isolating that natural log. Divide both sides by 3. I get natural log of x plus 2 equals 3. Now I want to change forms. If it helps you, go ahead and rewrite natural log as, the computer is doing something weird, there we go, log base e of x plus 2 equals 3. Okay, so those two are equivalent expressions, so I get e to the 3rd power equals x plus 2, and so e to the 3rd power minus 2 equals x. If this was a non-calculator part of the test, that would be the best you could do. If you had a calculator, you could do e to the 3rd power, which is about 20.01, and then subtract your 2, which would give you 18.09. So it just depends on which part of the test you would be on. I want you to practice both, the exact value and the rounding form, so you are familiar with e on your calculator. Okay, so let's take a look at 5. 5, it's the first time we see 2 logs in the equation. Notice that these logs are both log base 4. This only works if your logs have the same base. If they do, you can set their arguments equal to each other. So 5x minus 7 equals x plus 5. Well, now we're back in Algebra 1. Subtract x. I get 4x minus 7 equals 5. Add 7. 4x equals 12. So x equals 3. Done. Again, we could do that because the logs on both sides were set equal to each other and had the same base. Same thing on 6. Notice that these are both natural log. Remember that natural log is log base e, so these two logs both share the same base. So I can set their arguments equal to each other. 2x plus 8 equals x plus 12. Subtract x from both sides. X plus 8 equals 12. Subtract 8. And so x equals 4. So that's it. We have solved equations using logs, either 1 log or 2 log. I want you to use those 6 examples and practice using these video examples. Notice that these 6 examples parallel the examples that I just showed you, so if you have any troubles or questions, you can look back to the 6 examples we just did together. Thanks for watching my video.